Hello everyone, today we're going to be talking about wind and water problems. These are also known as rate problems. So this video is just going to be a pretty brief introduction to how these problems work. I'm going to go over the basics and then we're going to dive into some practice problems. So let's get right into it. So wind and water problems consist of just three things. First thing is the distance, which is just how far you're going. Next thing is the time, which is how long it takes you to get there. And then your distance and your time are connected by the rate, which is your speed, is another way of talking about that. So, for instance, when you're in a car, you're moving at a speed of 60 miles an hour. It's the same as a rate. And now your distance, your rate, and your time are connected by this simple formula. Your distance is equal to your rate times your time. For instance, if you're traveling at a rate of 60 miles an hour and you travel at 60 miles an hour for 1 hour, you get your distance, which is just going to be 60 miles. Simple enough. And this is how I like to write it. As you get familiar with it, you'll be able to just write it as D is equal to RT. So in these problems, our goal is usually to find all three values, because we want to know the distance, we want to know the rate, and we want to know the time. So here's a pretty simple practice problem. We have a car traveling at a rate of 30 miles an hour. We want to find how far it travels in 6 hours. So the first thing we're going to do is try and take all the information out of this problem and write it down. So the first thing we notice is that our car is traveling at a rate of 30 miles an hour. So we'll write that down. Our rate is 30 miles an hour. The next thing we see is that it is traveling for a time of 6 hours. So our time is going to be 6 hours. And you'll notice the problem doesn't say anything about the distance, so distance is our unknown, and that's what we're going to solve for. So here's our solution. Just quickly rewrite the problem and our information that we know, and then here's our formula. Distance is equal to rate times time, and all we're going to do is plug our known values into this formula and try and solve for our unknown value. So here our known values are our rate and our time, so we'll plug those in. So now our distance is equal to 30 miles an hour times 6 hours. When you compute that, the hours will cancel out. You get 30 times 6 miles, which is 180 miles. And that is going to be our final solution. See, not so bad. Alright, so let's get into the first of our example problems. So in this first one, we have a boat. It's traveling at a speed of 20 miles an hour. We want to know how many minutes it's going to take for it to travel to its destination, which is 15 miles away. Now, if you think you can solve this one on your own, go ahead and pause the video right now, try and work it out. And I'm just going to go through the solution right now. So first thing we want to do is just write down our formula. And next, we're going to take out all the information that we can out of this problem. So once again, our rate, okay, it's going to be 20 miles an hour. And we know that our destination is 15 miles away. That's going to be our distance. And now we want to know how long it takes us to get there. So we're going to solve for our time. So you can see I've rewritten our formula up here. We're going to solve the problem below. We're going to plug in our known values. We have a distance of 15 miles, which is equal to our rate of 20 miles an hour times our time. If you divide both sides by 20, you see that our time is 15 over 20 hours. But we want our time in minutes, so we need to convert our time, which is 0.75 hours, into minutes. Now the way that we do this is we know that there are 60 minutes in 1 hour, so if we multiply 0.75 by 60, we will get a time of 45 minutes. Okay, next problem. Flying by plane, the distance from LA to New York is 2,500 miles. This flight takes the pilot 6 hours and 15 minutes to complete. We want to know what the speed of the plane is during the flight. So once again, I'm just going to write down our formula. D is equal to R times T. We know that our distance is going to be 2,500 miles. And now we know our time is 6 hours and 15 minutes. And here we need to find the speed of the plane or our rate, and that is going to be our unknown value. So there's a small problem with this example problem. and that is that our time is not in consistent units. You can see we have part of it is in hours and part of it is in minutes. And if we're going to solve this problem correctly, we need our time to just be in one unit, which means we need to convert the 6 hours 15 minutes into just hours or just minutes. Now I'm going to recommend that we convert it into hours because that's how we did our previous problems, and our distance is 2,500 miles, and if we have a time in hours, then we get a rate which will be in miles per hour. Alright, so if we convert our time, we know that 15 minutes is going to be 15 minutes out of 60 minutes. When we convert that into hours, and then we add that to our 6 hours, and we get a time of 6.25 hours. Now when we plug all our information back into our formula, we have our distance 2,500 miles is equal to our rate times 6.25. Now we divide both sides by 6.25 to find our rate. You get 2,500 divided by 6.25, and you work that out and you get a rate of 400 miles per hour. Alright, and for our last problem, we have a boat that travels at 12 miles an hour in still water, and it's moving against a current running at 3 miles an hour. And we know that our boat is going to run out of gas in 2 hours. We want to find how far it will have traveled once its tank is empty. Okay, so we notice a couple things here. We have the rate of the boat and we have the rate of the current. And then we know that our time is going to be 2 hours because that's the longest amount of time we can travel until we're out of gas. So we'll just write down our boat rate, which is 12 miles an hour. We'll write down our current rate, which is 3 miles an hour. And then we'll write down our time, which is 2 hours. So when we solve these problems, we need to just have one rate. We can't use the boat rate and the current rate. So we need to combine these into one somehow. Well, what you'll notice is the boat only moves at 12 miles an hour in still water. But in this problem, it's moving against a current. It's moving at 3 miles an hour. So when we combine these two, we need to either add the rates together or find the difference between them. So what do you think we should do? Should we add the rates or should we subtract them? Well, if you think about if you're running into the wind, you're trying to move one direction, but the wind is trying to push you back the other direction. So the wind is slowing you down. It's taking away some of your speed, essentially. So in this instance, we're going to want to subtract our current rate from our boat rate. So our actual rate will be 12 miles an hour minus 3 miles an hour, which gives us 9 miles an hour. And that makes sense because the boat is moving up at 12 miles an hour and the current is pulling it back at 3 miles an hour. From there, it's pretty simple. Same process that you guys know. Start with our formula. Distance is equal to rate times time, and we'll plug in our known values. Our distance is equal to 9 miles an hour times 2 hours, which gives us a distance of 18 miles. Alright, that's all I have for you guys today. Thanks for watching. Thanks for listening. I'll see you in the next one.